So, you've got a Java interview coming up, huh? Well, let's just skip all the stress and cut right to the good stuff. In the next few minutes, we're going to arm you with the confident answers you absolutely need to know. Let's be real for a second. Technical interviews can be pretty nerve-wracking. You can study for weeks, but there's always that nagging question in the back of your head. What are they actually going to ask me? Don't worry, we've got you covered. We're about to break down 5 of the most fundamental questions that form the bedrock of pretty much any junior or mid-level Java interview. If you stick with me, I promise you'll walk out of here with clear, confident answers for every single one. All right, let's dive into question number 1. Now, this sounds super basic, but you should not underestimate it. When an interviewer asks, "So, what is Java?" they're not just looking for a textbook definition. They're checking to see if you really get the core identity of the language. Okay, here are the magic words you want to hit. Java is a high-level, object-oriented language. But the real showstopper, the thing you have to mention, is platform independent. What does that mean? It means you can write your code one time, and it'll run pretty much anywhere. A Windows PC, a Mac, a Linux server, you name it. And it's all thanks to the Java Virtual Machine, the JVM. That one feature is exactly why Java is such a powerhouse for everything from the Android apps on your phone to massive, complex systems run by big companies. So that whole write once, run anywhere thing is a really powerful promise, right? Well, interviewers are going to want to know if you understand the machinery that actually makes it happen. And that brings us perfectly to question number 2. What is the difference between the JDK, the JRE, and the JVM? Let's start from the very center and work our way out. At the core of it all is the JVM, the Java Virtual Machine. You can just think of this as the engine. It's the piece of the puzzle that takes your compiled Java code, which is called bytecode, and translates it so it can run on whatever specific machine it's on. Now, an engine can't just run in a vacuum, right? It needs the rest of the car built around it. Well, that's the JRE, the Java Runtime Environment. It's the JVM plus all the libraries and other files that a Java program needs to actually execute. So if you're just a user who wants to run a Java app, the JRE is all you need to install. And finally, for us developers, there's the JDK, the Java Development Kit. This is the whole shebang, the complete toolbox. It includes everything that's in the JRE, but it also adds all the tools we need to actually write and build our applications. Most importantly, the compiler. So to put it all together real simple, as a developer, you use the JDK to write your code. Your user needs the JRE to run that code. And deep inside that JRE, it's the JVM that's doing all the heavy lifting. It's a nice, clean hierarchy. The JDK has the JRE inside it, and the JRE has the JVM inside it. Easy enough, right? Okay, on to question 3. This one really gets into the why. You know, why is a language that's been around for decades still one of the most popular choices in the world? Interviewers want to know if you get the features that make Java so incredibly reliable, especially for those big, complicated projects. You want to show you understand how these things actually help a development team. I mean, besides being platform independent and object-oriented, Java was built from the ground up to be secure and robust. It's also got some seriously powerful tools baked right in, like multithreading for handling a bunch of tasks at once and automatic memory management, which is a huge lifesaver that prevents tons of common bugs and saves developers countless hours of headaches. It really all adds up. And that brings us to a really big one. Question 4. This is all about the principles of object-oriented programming, or OOP. And this isn't just a Java thing, you know? It's the whole philosophy that helps us programmers build complex software that we can actually maintain without going crazy. And Java is a textbook example of OOP done right. There are 4 main pillars you absolutely have to know. They're a fantastic way to think about organizing your code. They are encapsulation, inheritance, polymorphism, and abstraction. So let's take a super quick look at what each one brings to the table. First up, we've got encapsulation. The easiest way to think about this is like one of those medicine capsules. It bundles the data, the medicine, and the code that works on that data, the protective coding, all into one safe little package. This protects your data from being accidentally changed from the outside, which is absolutely vital for building secure and predictable code. Next is inheritance, and this one is all about not having to write the same code over and over again. It lets you create a general parent class, and then more specific child classes can just inherit all its features. For example, you could make a vehicle class, and then your car and motorcycle classes could just inherit all the basic stuff from it. Super efficient. Then we have polymorphism, which literally just means many forms.
It's this really cool idea that lets a single action behave differently depending on what it's acting on. So you could have one speak command, and a dog object would bark while a cat object would meow. It makes your code way more flexible and dynamic. And finally, there's abstraction. This is all about hiding the messy, complex reality and only showing the essential parts. Think about driving a car. You see a simple steering wheel and pedals, right? You don't see the complex engine mechanics working underneath. Abstraction does the exact same thing for our code, making it so much easier for other programmers to use and maintain. All right, our final question. This one is a classic gotcha that can trip up even developers who've been doing this for a while. It seems so simple on the surface, but it reveals whether you really get how Java thinks about objects. The question is all about the two ways you can check if things are equal, using the double equals operator versus the dot equals method. Okay, listen up, because this is the critical difference. The double equals operator checks if two variables are pointing to the exact same object in memory. It's like asking, are we both pointing to the very same physical book on the shelf? The dot equals method, on the other hand, checks if the content is the same. That's like asking, do our two different copies of this book have the exact same words inside? See the difference? Now, this is most important when you're dealing with objects like strings. Let's say you have two different string objects, and they both contain the word hello. If you use the double equals operator, it might tell you they're not equal because they live in different spots in memory. To actually check if the text itself is the same, you must always use dot equals. This is a non-negotiable rule you just have to burn into your brain. So let's do a super fast recap. Number 1, Java is platform independent and object-oriented. 2, the JDK contains the JRE, which contains the JVM. 3, its key features make it secure, robust, and fast to work with. 4, the 4 pillars of OOP are encapsulation, inheritance, polymorphism, and abstraction. And 5, use double equals for memory location and dot equals for comparing the actual content. You master these 5 answers, and I guarantee you'll have a rock-solid foundation for any Java interview. You'll be showing them that you don't just know the what, you get the critical how and the why behind the language. Now go out there and absolutely ace that interview. You've got this.